Welcome to Virtual Pathfinder YouTube channel. This video is an update about the Indian space mission Chandrayaan 3, which successfully landed a lunar lander and a rover on the 23rd of August. The moon is rotating 360 degrees in about 28 days, which means that the lunar daylight is 14 Earth days and the lunar night is also 14 Earth days. The Chandrayaan 3 lander touched down near the Manzinus crater at latitude 69 degrees south and longitude 32 degrees east, not far from the South Pole. Now, in early September, it is sunset at that location and the lunar night starts around the 5th of September, which can be seen when displaying day by day how the shade is progressing along the lunar surface in Sky Safari Pro. According to the mission description, the mission lasts one lunar day and will end when the lunar night begins after 14 Earth days. The reason is because the lander and rover are not expected to function after 14 days in darkness at temperatures around minus 120 degrees Celsius. When the sun sets at the lunar horizon, the solar cells will no longer receive light and the backup batteries will gradually be depleted. However, my guess is that there is a good chance that the equipment will come to life again once the sun rises in the next lunar morning. I suspect the engineers have made efforts to protect the equipment as much as possible, but they probably didn't feel confident enough to make any promise. In my opinion, extreme cold is a lot better than extreme heat for electronics, especially when there is virtually no atmosphere. So I think the odds are good. That would be a victory on top of a victory for ISRO, the Indian Space Research Organization. It is something to look out for around the 20th of September. Regardless if that happens or not, Chandrayaan 3 is already a huge success, and it has made India the fourth nation to land on the moon. Although the landing site is in the South Pole region, it is still on the 69th parallel south, which is 31 degrees from the actual South Pole. The conditions there are a bit different from other locations on the moon, and the big question about the existence of large amount of frozen water in the polar craters remains unanswered until a space mission has successfully landed closer to the South Pole. The soft landing of the lunar module is in of itself a huge success, which places India as the fourth nation to land on the moon. What makes it even more remarkable is that India turned out to be the first player to enter the South Pole region, which is the location all the major players are aiming at. It would have been different if the Russian Luna 25 mission had successfully landed as planned, not far from the Chandrayaan 3 landing site. Considering Russia's long history of space missions, it would have been less surprising if Luna 25 had been the first to land near the South Pole. The Chandrayaan 3 mission description states that the goal is to soft land the lander and to drive the rover near the landing site and to perform scientific experiments. So what has been achieved so far? The lander has measured the surface temperature and created a temperature profile down to 10 centimeter depth. It was found that the surface temperature is about 50 degrees Celsius and that the temperature rapidly falls down to minus 10 degrees Celsius 10 centimeters under the surface. As far as I can tell from the profile, the freezing point is about 70 millimeters under the surface. The Chandrayaan 3 rover has a laser-induced breakdown spectroscopy instrument on board, which has analyzed the composition of the surface. It has detected sulfur on the surface near the lander, which was not known before. Preliminary analysis have unveiled the presence of aluminium, sulfur, calcium, iron, chromium, and titanium. Further measurements have revealed the presence of manganese, silicon and oxygen as well. Thorough investigation regarding the presence of hydrogen is underway. An instrument on the lander has measured the plasma density near the lander, in other words, the density of charged particles near the lunar surface. The initial observation indicates that the plasma near the lunar surface is relatively sparse, with a density ranging from approximately 5 to 30 million electrons per cubic meter. This data was from early stages of the lunar daytime. The probe operates without interruption, aiming to record changes throughout the lunar day. This data is useful for comprehending the process of charging within the lunar near-surface region, particularly in response to solar fluctuations. There is also an instrument on the Chandrayaan-3 lander for measuring lunar seismic activity. Its primary objective is to measure ground vibration generated by natural quakes, impacts, and artificial events. The vibrations recorded during the rover's navigation on August the 25th are depicted in the measurement data. Additionally, an event seemingly natural recorded on August the 26th can also be seen in the measurement data. The source for this event is currently under investigation. On Sunday, the 3rd of September, the rover was put into sleep mode after it had completed all of its assignments. Its batteries were charged and receiver left on in preparation for the lunar night. The rover's collected data has been transmitted to Earth via the lander. The lander and the rover are expected to operate only for one lunar daylight period, which is 14 Earth days. The onboard electronics are not designed to withstand the minus 120 Celsius nighttime temperatures on the Moon, which is minus 184 Fahrenheit. If the rover and the lander were to survive the lunar night, the mission is planned to be extended for further science operations. We will find out if that is the case sometime around the 20th of September 2023 at sunrise, when the new lunar day begins. Apart from the operational success, ISRO has managed to accomplish all of this on a shoestring budget, spending only about 6.15 billion rupees, or about 75 million US dollars. That in of itself is fantastic, especially when comparing to the cost of other lunar missions. For instance, Russia's robotic mission Luna 25, which tragically crashed on the Moon shortly before Chandrayaan-3's landing, reportedly had a budget somewhere around 200 million US dollars. NASA, the United States Space Agency, is projected to allocate as much as 93 billion US dollars for its Artemis moon exploration program by 2025. Of course, the Artemis program is not comparable since it's more extensive and it includes crewed missions, but it is impressive to see how much can be accomplished with a 75 million US dollar budget. India's space program is an interesting case, not only for its recent accomplishments, but also for the future strategic alliances in space exploration. As a partner for small players as well as big players, India's ability to produce results at a low cost will draw attention. For the US and its allied countries, geopolitics has made it impossible to cooperate with the two other players on the Moon. For Western countries, the war in Ukraine has made cooperation impossible with Russia. At the same time, economical and geopolitical rivalry has prevented cooperation in space with China. India is a different story. As a democracy standing in between, there is a potential for future cooperations with other nations, regardless of their budget size.